The Jordan Show on YouTube.
Hey everyone, welcome back. Ready to dive deep again.
Absolutely. Always ready to explore.
Well, today we're taking a look at a company that's kind of a hidden giant,
I think I know where you're going with this.
They're not a household name exactly, but their work is everywhere, literally in the palm of your hand. We're talking about Applied Materials.
Ah, the unsung heroes of the digital age. You don't see their logo on your smartphone, but they're a cornerstone of the entire semiconductor industry. Without them, well, things would be pretty different.
Yeah, no kidding. Our phones would be bricks, our computers wouldn't exist. Pretty mind-blowing when you think about it. So for this deep dive, we're going to uncover how Applied Materials rose to become this powerhouse. We've got a ton of fascinating material to dig into, stories about the brilliant minds who built the company, the game-changing innovations they developed, and how their work has shaped the technology we use every single day.
It really is a remarkable story. From a small startup to a global giant, they've been at the forefront of the chip-making revolution for decades.
And to understand how they got there, we needed to go back to the very beginning. 1967, Silicon Valley is just starting to blossom, and two engineers, Michael McNeilly and Arthur Mathews, have a vision.
They saw an opportunity. The semiconductor industry was in its infancy, but it was clear that it was going to be huge. The problem was there wasn't reliable equipment to manufacture these tiny, incredibly complex chips.
So they basically said, hey, we can build that equipment, and that's how Applied Materials was born.
Exactly. And right from the start, they focused on two crucial processes, etching and deposition. Now, these might sound a bit technical, but they're the fundamental building blocks of chip making.
Okay, break it down for us. What exactly do etching and deposition do?
Imagine you're sculpting a tiny, intricate statue, but instead of chisels and hammers, you're using incredibly precise tools that work at the microscopic level. Etching is like carefully removing material, carving out the chip's features with incredible accuracy.
So it's like a high-tech version of Michelangelo chipping away at a block of marble.
And what about deposition? Deposition is the opposite. It's about adding material, building up the chip layer by layer. Think of it like a super sophisticated spray painter, laying down incredibly thin, uniform layers of material to create the chip's structure.
Wow, it's amazing to think they were already working at such a tiny scale back in the 60s. But I think it's safe to say that the company really took off when James C. Morgan stepped in as CEO in 1977.
Ah, James Morgan. Now, he was a true visionary. He knew that to succeed, Applied Materials couldn't just be a tool supplier. They needed to become a true partner to the chip makers, working hand in hand to push the boundaries of what was possible.
That's such a key insight, right? Realizing that the whole industry would advance faster if they collaborated. Yeah. So who were these key partners that Morgan cultivated relationships with?
Well, two of the biggest names in the game, Intel and TSMC. These companies were making the most advanced chips in the world, and they needed cutting-edge tools to do it.
It sounds like a perfect match. Intel pushing Applied Materials to innovate, and Applied Materials providing the tools that enabled Intel's breakthroughs.
Precisely. It was a truly symbiotic relationship. And this collaboration really bore fruit in the 1980s, which was a decade of incredible innovation for Applied Materials.
This is where we start to see some of the technology that really shaped the modern world, right? Like chemical vapor deposition, or CVD as it's known, and also plasma etching. These sound super complicated. Can you give us a simple explanation of what they did?
Sure. Let's start with CVD. This was a game changer for creating incredibly thin and uniform layers of material, crucial for building more complex and efficient chips. Think of it like 3D printing, but at the atomic level.
Whoa, atomic level 3D printing. That's pretty wild.
Yeah.
And plasma etching, what was so special about that?
Plasma etching provided a whole new level of precision. Imagine a tiny, highly focused laser beam, but instead of light, it's using a plasma to etch the chip's features. It allowed them to create much smaller and more intricate designs.
Okay, so that's why our phones can do so much more today than, say, 30 years ago. The chips are just way more powerful and efficient.
Exactly. And it's not just about the tech itself. James Morgan cultivated a culture at Applied Materials that encouraged risk-taking and out-of-the-box thinking.
He wanted his engineers and scientists to really push the limit.
Yes. And it wasn't just about working with big companies either. There were brilliant individuals making incredible contributions, like Dr. Chih-Tang Sah.
Right, Dr. Sah. He was a pioneer in thin film technology. Wasn't that all about making these layers of material that are just a few atoms thick.
That's right. His work was instrumental in increasing a chip's processing power and energy efficiency. And it all came from this environment where people were encouraged to experiment, collaborate, and, maybe even break things a little bit in the process.
And all of this, from the visionary leadership of James Morgan to the ingenuity of people like Dr. Sah, had a profound impact, not just on applied materials, but on the entire tech industry.
It's no exaggeration to say that applied materials has been a driving force in the digital revolution. They've helped create the tools that power everything from smartphones and laptops to artificial intelligence and self-driving cars.
And as we look to the future, with technology evolving faster than ever, it makes you wonder, what role will applied materials play in the next chapter of this incredible story?
That's the big question, isn't it? What new innovations will they come up with? What challenges will they overcome? It's exciting to think about the possibilities.
Absolutely. Their journey from a small startup to a global powerhouse is a testament to the power of vision, collaboration, and pushing the boundaries of what's possible. And that's what makes this deep dive so fascinating. It's a reminder that behind every technological marvel, there are countless unsung heroes quietly shaping the world we live in.
And who knows what amazing things they'll create next. That's the beauty of this industry. There's always something new on the horizon.
And we'll be here to dive deep into those innovations, explore the stories behind them, and uncover the impact they have on all of our lives.
Always excited for the next deep dive. Until then.
See you next time.